Hi, everyone. Hi, everyone. I'm Hussain Muscati. I'm a customer engineer at Google. And my colleagues here as well, Justin Grayston is also a customer engineer. We work with customers to help build and design solutions for the cloud. So today we're going to be talking to you about Knative. And that is basically Google's vision on building a serverless platform on top of Kubernetes. So I did mention Kubernetes, and usually when you hear Kubernetes, you think about a cluster and so on. So are we actually going to be talking about servers at a serverless conference? Well, yeah, I mean, we're going to be using it as a building block to Knative, and we'll touch on that. So there are two kind of things that we're going to be talking about mostly, Kubernetes and serverless. And we're going to showcase the best of both worlds. With Kubernetes, it changed how development works in the terms of being able to deploy an application on many, many machines. While with serverless, it changed how developers deploy their applications and have them run without needing to think about the resources needed. So let's start by talking about Kubernetes. So who here has used Kubernetes before? Can we see a show of hands? Okay, quite a few. Who here likes Kubernetes?
Slightly less.
Who here does not like Kubernetes and never wants to work on it again?
Hey, that's not bad.
Okay, that's not bad at all. Okay, so as probably most of you know that Kubernetes is the de facto platform for running containers. I mean, when you're developing application, no one wants to be running their own orchestration platform. Everyone wants to be using something that can manage all that. And that's what Kubernetes is there for. And this is just to kind of show you how big the Kubernetes ecosystem is. I mean, you have all these companies that are actually developing on Kubernetes. You have thousands of contributors, tens of thousands of GitHub stars. There's just a lot happening in the industry in Kubernetes. And how did this actually happen? How did we get to this point? Well, if you think about this, Kubernetes actually encourages cattle, not pets. You're not thinking about an individual entity. You're thinking about the whole group. You're thinking about the herd. Individual machines don't really matter. Your containers kind of isolate the app from the host. And containers can come and go while your application is deployed on multiple containers. And that is kind of the main idea behind Kubernetes. And one of the other good things about Kubernetes is that it has a declarative API, which means you have a cluster and you want to be able to configure it. You can easily do that via the API. So all you would do basically is configure based on your desired configuration, and Kubernetes will take care of moving it from one state to the desired state. The other good thing about Kubernetes is that it keeps your application running even while you're asleep. Let's say your container died. What do? Kubernetes will restart it. Your container is unhealthy. It will get rescheduled to another node. Let's say your container is overloaded. Kubernetes will take care of replicating and scaling as needed. And Kubernetes is also very configurable. The API is extensible. You can do all kinds of things like custom API types and write custom controllers, etc. So you can go crazy with this. Having mentioned all that, it seems like a walk in the park, right? Well, I mean, not so fast. Kubernetes, in the end, is not that easy. The thing is, it was never really meant to be used by developers directly, because creating and operating Kubernetes clusters in production is pretty much a full-time job. You'll see people with a DevOps job description, because that's what they do. They manage these Kubernetes clusters. And to be honest, as a customer engineer, we tend to work with a lot of customers that want to do Kubernetes or want to use Kubernetes, but don't necessarily have the skill or the knowledge, and they need to spend a lot of time building that to be able to start using it. So it's not that easy. So there are multiple managed solutions for Kubernetes out there. Google Kubernetes Engine is one of them. They provide zero ops experience. Like, it gives you updates to your cluster, to new versions of Kubernetes automatically. It helps you scale your cluster up and down automatically, and also helps you detect and replace broken nodes. Going back to the statement, Kubernetes isn't actually for developers. Think about it. What does a developer want to do? They just want to write code that impacts the logic of their application. It's not the right abstraction for end developer experience, if you think about it that way. It's a great platform for building a platform as a service on top of. So you'll see where I'm heading with that. Imagine you have a developer using Kubernetes. What do they have to do? They need to write code, and hopefully if you're a developer, you should be writing code. You should be able to build a Docker image. You need to upload images to a registry, which is quite a bit of work. You need to deploy a service and be able to expose it to the internet if needed. You also need to be able to set up monitoring and autoscaling, where an actual developer, all they actually want to do is just write code. But why do developers actually use Kubernetes? Because a lot of people want control over their infrastructure. They want to be able to control the VMs, machines, the OS images, networking, security, etc. And you'll see in the industries, a lot of companies are still not on the cloud yet. They're still deploying on-premise. And they want to avoid vendor lock-in. And containerization is a great way for that. And Kubernetes helps you orchestrate these containers. And the other thing is that when you're talking about massive scale, Kubernetes lets you very effectively manage a large set of machines and deployments. So we talked a bit about the Kubernetes part. Let's talk about serverless. This is something we think at Google. Serverless is a lot bigger and a lot more than just functions. A lot of the time in the industry, when people think about serverless, they think about taking a snippet of code and running that on the cloud and getting results out of it, or maybe running it based on a trigger. We see at Google serverless as at a much bigger scope than that. It's more of a mindset and how you actually develop a platform rather than just taking snippets of code and running it on the cloud. And we see that in the sense that serverless needs to be when you're building a messaging platform. It involves compute, it involves machine learning, storage, data processing. You don't want to be thinking about your infrastructure when you're a developer and you're developing some application on the cloud. You want to be able to just deploy that application and have it run. And that's how Google envisions serverless as. And this is something Google has been working on for a very long time. We have a lot of solutions available that encapsulate that vision, where basically serverless is well beyond taking snippets of code and running them on the cloud. So what does serverless give us? It gives us a bunch of things, like having no servers, as a perception to the user, event-driven, etc. And if you think about it, that's kind of where we want it. That's what we want to achieve. I mean, for an operator, it's good because they don't want to have to deal with the infrastructure. And for a developer, it's also good because they can just deploy their code and have it run and scale as needed. So what do developers want to do, essentially? They just want to run their code. They want to use their favorite language, their favorite environment. And they don't want to manage the infrastructure. So let's try to bring both of them together. And let's make a case for serverless on Kubernetes, because we talked about how operators generally like Kubernetes because they let them manage the infrastructure, and how developers love serverless because it helps them just deploy code and not having to think about the infrastructure. So developers want serverless because they just want to run their code. Operators want Kubernetes because it's great at orchestrating microservices. So how do we bring these two things together? Because developers don't want to manage the infrastructure, and operators want something easier to work with. So why would you want serverless on Kubernetes? Well, there are currently, and I think we actually have a much higher number now, 13 plus open source projects that are Kubernetes based, that are trying to do functions as a service, or like building a serverless platform on top of Kubernetes. So this is something that people are already exploring in the industry. Some motivation on why do you actually want to do serverless on Kubernetes. Let's say, for example, your company doesn't use cloud, so they don't want vendor lock-in. They want to avoid that. Or let's say you want to be able to control your infrastructure, and Kubernetes is a great thing to build on. These are the kind of things that motivate someone to build on Kubernetes. To be able to actually get that serverless vision or serverless approach to Kubernetes. And that's kind of what we're trying to get here. So think about this statement for a bit. The majority of people actually managing infrastructure just want PaaS. because the ones managing the infrastructure are either operators who are providing a solution for their developers or developers who are using the platform. And they just want it, for developers, they just want to run their code. So that a PaaS platform is what they're actually looking for. They just have one requirement. They want to build it themselves. So how do you actually work with that? Think about this for a sec. Let's say you actually try to do that and build a serverless stack on top of Kubernetes. This is kind of the effort that is needed. You need to provide certain products, like on the top level, where you need to provide the runtime, event sources, and you're going to need to build a whole bunch of primitives, like the build, the auto-scaling, the event binding, etc. And the thing is, with the products, that's an opportunity loss because there's no sharing there. And with the primitives, there's just so much duplication there. And it makes it non-portable. So what do we do? How do we solve this problem? What if we tell you that you can actually do this and fulfill the serverless promise on servers such that you don't have to manage them? That's where we talk about Knative, and Justin will take you to the rest of the talk.
I'm all right. I think I've got a mic. It's working. OK, so yeah, as per the introduction, and next San Francisco, we launched Knative. And I think there's, as an introduction, our engineering department have been thinking about this for a while. It's like, the objective is to create the building blocks for creating those serverless experiences that everybody wants. And I think there's two areas here. There's the engineering problem, like in the product sense, it's like, how do we do this? But also, as Hussain was saying, we see our customers a lot. And I can think of three off the top of my head that I deal with right now who are busy creating a PaaS on top of Kubernetes. And I wonder if they all shared and actually talked to each other, how much quicker they could get to actually deploying something into production on their PaaS on Kubernetes. Now, some enterprises do this well. Some enterprises, not so well. So at both levels, we see this we've seen the problem. And then at the engineering level, as our engineers started to discuss with other people, other companies, we realized that everybody was working on a similar problem. So why not actually get together and instead of wasting that duplicated effort, try and come up with the standardized building blocks to do this on top of Kubernetes. And Pivotal have been core contributor. SAP have already started to use Knative, and Red Hat, IBM. They've also been key contributors. So I'd stress that was July, and on the day we announced it, so did Pivotal. We're still very at the beginning of this journey. Well, let's just take a look at the Knative stack. So you have Kubernetes, that's a given. And just think back to what Hussain was saying, currently a developer is going to have to build, they're going to have to serve, you're going to have to work out how to hook up events. So these are the three pillars that we're starting with Knative. By no means we're going to limit this to our scope, but this is where we're starting. So how can we build, how can we serve, how can we do events? And on top of that, you can then build those products. That was at the top of Hussain's slide. So these are some of the products that are already using the Knative building blocks to create these products. So serverless containers on GCF. And I'm sure there's going to be a lot more. So let's be clear about what Knative is. It is an open source project. It's that set of building blocks to construct your FAS or PaaS. And the idea is it extracts away quite a lot of these problems down to the Kubernetes API. But it is still Kubernetes. So if you know Kubernetes, you should feel quite at home. If you don't know Kubernetes, you don't actually need to know an awful lot about Kubernetes to make it to work. What it is not. It is definitely not a Google product. It is absolutely an open source product. And we want to have more contributors. And it's not functions as a service. It's trying to be much broader. So, what can you do with Knative? Okay, you can deploy stuff. I think we're on version, well, I know we're on version 0.2.0. We may get to 0.3 soon, maybe. So you can deploy stuff. This slide says not easy, but it's not too complicated, and it does work fine. For operators, it does nicely put that abstraction between your devs and your Kubernetes. They shouldn't really need to go near it. And for platform architects who are in the enterprise and they're trying to build their own paths, it should work for that. I would also add to that, where there are definite cases where you may be using managed serverless or PaaS in the enterprise, but there might be certain use cases where you want to keep something on-prem or in another cloud, and this could really, this is where Knative can really help. So your developers can literally deploy into off-the-shelf paths, managed paths, or into your in-house platform. The idea is the primitives stay the same, and the Kubernetes API stays the same. So we're not trying to make things complicated. So what are we trying to do when we create our DIY functions as a service on Kubernetes? Well, okay, we need something to wake up on a request, something to do something. It should scale up. There should be no effort to scale up. It should scale back to 0, which Kubernetes pods don't, but they do in Knative. You should be able to turn your app into a function if you want to, or app or function into a container. And you should be able to collect metrics, export telemetry, handle revisions of code and config, and the ability to roll back when it all goes horribly wrong, and a way to traffic split, so you can do canaries or gradual rollouts. And an eventing system with configurable source flows and subscribers. So that's what you'd need to do. So that brings us back to our building blocks. Okay, so Serving's responsibility in Knative is to handle the revisions, the traffic splitting, and the auto-scaling. Build, it does on-cluster builds and transformations. If anybody's used Google Cloud's Cloud Build, it feels very similar. And eventing, the declarative way to bind events to sources and services. So, what are the benefits? Well, as I said, it seamlessly scales up and down. It's got built-in traffic splitting, integrates with networking and the service mesh using Istio. Easy to reason about the object model, because we're not trying to do anything crazy. We're using Kubernetes. This is if you're native Kubernetes, hence the name. It's pluggable. So you're not bound to be, you don't have to, you can create your own logging. You can swap in and out parts. Because it's just using the API object model, you can use custom types. You can swap out the autoscaler to be any of your own code if you wanted to. And that's the key point here, is that we're trying to separate those concerns. So here with serving, you can see you've got the function or service, which is obviously backed up by a deployment. You've got configuration and a route that sends to revision. And each deployment is an immutable version of revision of that. So you can roll back very easily or split routing across those multiple revisions if you wished. Build lets you go from source code to container images. Kind of obvious. But you can build with multiple steps. Like I said, if you use Cloud Build, it's very similar. You can each build step runs in a container image, and the containers run on the cluster. So if you know Kaneko, it allows you to just literally, without Docker, build your container images. So it makes GitOps, or do a git push and deploy very easy. And that's an example config. You give it a source, go grab the source content, run these different steps, use these images for each step, pass the command across. So we turn the function to a deployment, And then the app gets turned into a container via build pack environment, and that container gets pushed to a container registry, which then can trigger it to be served. So the benefits of on-cluster building. So there's no cross-compiling toil, no need for Docker locally, cloud caching, so faster image push, and tooling ecosystems for enterprise policy and audit trails. It's loosely coupled. You can use it to get started. So my first question to the engineering team was, okay, cloud build, the Knative build. If I'm using GitLab or Travis or whatever, the CI/CD toolchain or Spinnaker, do I just throw all that out and just use this? Well, no. Because if you end up with an artifact, you can just simply serve that. If you have that artifact that goes into a repository, then you can just serve that. But it might be a case where you have ephemeral development clusters on Kubernetes, where you actually just want to very quickly just iterate, push on your branch, and see what that looks like within your system. So, Knative eventing. So, when I submitted these slides, this was correct. And in the past 3 weeks, 4 weeks since Google Cloud Next in London, actually the internals have actually been not completely changed, but changed quite significantly. But the benefits are still the same. You can declaratively bind between event producers and your service. And you can have custom event pipelines. I will talk about eventing a little bit more by going straight to the GitHub repo, which has the most current version. So at Knative, the development principles of Knative itself, it should feel like Kubernetes. We don't ever want to be messing around creating custom APIs. It should be completely 100% native Kubernetes. We should try to meet the developer where they are. They shouldn't have to understand the whole of Kubernetes to be able to use this. It should be extensible, so loose coupling at the top, pluggable at the bottom. And it should be organic. Codify the commonalities between the parts and build a stable platform, which is often much easier said than done. Okay, so demo. So I am going to come out of here. So as per my introduction, if you had DevOps, which I'm not sure I particularly like that term, but I'm definitely more on the dev side than the ops side. In fact, that's why I got into App Engine, is because I could then go from having to deal with my system operators to being able to have a team, deploy stuff, serve it, have millions of users use it. It was, that's the experience that I like. Personally, I don't want to have any friction in the way whatsoever. However, that being said, even I managed to get this working. So this is, I'm doing Kubernetes the easy way. So I'm using GKE, obviously, because I'm Google Cloud. So that was very easy to set up. And then I just went to github.com/knative docs/install. And there's some great install steps for many of the clouds. And I just went through those install steps. And if I just spin up, we should have, boom. And if you follow the install steps, it comes with Prometheus, Elastic, and Kibana. Quite common open source stack, but it all comes and it all works out of the box. I'm not sure about day 2 ops. I'll tell you that if you follow me on Twitter if I'm crying in a few weeks' time. So I got all this working. Okay. So let's see which one. Okay, so this is my, see, I use kubectl, get pods, -w. So, as you can see, the only thing that's running there is the external DNS. I've actually done 2 deploys of the Hello World already. If I go to here, we've got the Hello World Python. If I just refresh that, it's a cold start. We all know about cold starts. And if I come back, if I put that on screen as well, that on screen as well, we should see, look, pod initializing. There we go. I just refreshed. So it's internet. So there we go. So we should now see that we have 3 pods running from that. So this service, really easy, scale back to 0 because nobody had used it. So what I'm going to do now is I'm going to go to, I'm going to deploy a Rust version. Okay, so this is a really weird angle to be typing at. So where are my docs? Samples, serving, samples. Hello world, Rust. Okay. So basically what you would do here is inside there we go, we've got a Docker file. Pretty simple. And what this is going to do is I'm glad I did this before when I had a decent internet connection. I built the Docker image and I pushed it to my Docker Hub repo. And so I have the Rust image deployed to here. And this is basically your service. This is just an app. Just give it an image, location in a repository, and you just do the configuration of how you want that to work. And all it's going to do is this environment variable is going to push into the app itself. So now we just do kubectl y-f service bump -r. Up it goes. Now if I change that to Rust, wait there. kubectl get pods, pod initializing. So it shouldn't be pulling the image because I've already tested this downstairs. There we go. We've got 2 running. There we go. Bing bang bosh. Yay! Round of applause, please. Okay. So that's serving. It should be a lot easier than that. But you see, it's not that much for somebody to, if you have an ops team looking after the cluster, and you have a dev team, and they want to deploy, they really don't need to get really very close to Kubernetes. Now, do I feel brave? Here we go. Okay, so shall I attempt to build from source and see what happens? Okay, so this is the configuration for a service. It's going to pull source code. It's going to compile it using Canaco. It's going to build the Docker image using Canaco based on the Docker file, which is very, very, very simple. Not a lot to it. And then it's going to deploy it. So I'm going to just I'm going to change that so you can see it's actually me. Okay, so now I do kubectl apply -f service. Okay, so that's gonna do that. Same thing again. Get pods -w. Okay, so you see it's initialized stage 1 of 3. It's stage 2 of 3. So stage 2 of 3. So it's gone and got the code. And now it's doing the build step here. So it's going to build that Docker image. That scared me, but that's you see here. This is because nobody's hit the Hello World Python. It's scaled that back. It's actually terminated those pods to free up resources. Not because it needs it for this. It's just literally because it's hit the timeout. So we'll wait for a few seconds. So once it's built that, it's going to push that to that Docker Hub. Here we go. So I'm going to reach for here. There we go. There's the pods coming up. And what was it called? App from source. App from source, default, Knative. There we go. Hello, service clean, this time in bold. And then H1 tag. Okay. So we got there. That's a relief. Okay, so eventing. So there's the 2 pillars in very simple steps. All these samples are in the GitHub repo, and if I can make them work, then I'm sure most people can. So eventing. This has changed a little bit. So the idea is this page has just recently been updated 3 days ago. We're basing all of the eventing around cloud events, which is one of the serverless working groups inside CNCF. And it's going to, as I said, we're in early stages, so there is a pull request for a demo, but it's not quite working at the moment. Well, at least I couldn't get it working. But I think this is about to drop in the next week or so. And the idea basically is you basically have a service object, which is like your deployment. You have sources, and you have channels. And sources go to channels. Channels can go to or one-to-many relationship with many different deployments, so services. As you can see here. Now, the idea is you could use, so by default, it uses in-memory streaming in a channel. And at the moment, and again, it's definitely not ready for production, and there's no guarantees that you may lose events. So you can use, as a source, you could use PubSub, a NAT stream, or Kafka. You can use Kubernetes events. Could be a sources of events. GitHub. GCP, of course. GCP PubSub, of course. And container-sourced events. And the general idea is that you should be able to take what you currently use. So if you're like using Kafka, you should be able to integrate this reasonably painlessly. If you're using PubSub, you should be able to integrate this really easily. And where I see, this is the bit that really excites me. I know you've got loads of open-based functions as a service, but having this nailed, where you can have interoperable events across on-prem, across between different clouds, for me, that's where we all want to be headed, really. So you could let me say using Cloud Functions or Lambda, processing a feed from PubSub, Kafka, and then in another cloud or on-premise, you have your Kubernetes with Knative pulling from those same sources, and it's your code can be shipped between, and you don't have to have that different configuration. So not a lot of detail on eventing, but it is at GitHub, Knative docs, Treemaster eventing. And there will be some demos landing in the next week or so.